A simple random sample of front seat occupants involved in car crashes is obtained. Among 2,823 occupants not wearing seatbelts, 31 were killed. Among 7,765 occupants wearing seatbelts, 16 were killed. So this is the thing we're going to be testing here. All the information is going to come from this. We're going to use a 0.05 significance level to test the claim that the fatality rate is higher for those not wearing a seatbelt. So let's write out the information we know. So for the first group, 2,823 occupants not wearing a seatbelt, 31 were killed. And since we're testing the claim about the fatality rate, our particular value we're looking at is the ones who died, 31. So x1 is going to equal 31, and the total number of people in this group is 2,823. Now for the second group, we see that 16 were killed. So second group, we have 16, and the total number in this group is 7,765. We also see that we have a significance level of 0.05, so our alpha value is going to be 0.05. Now, all this information is written out. Now we need to write out our hypothesis tests. So we're going to have our null hypothesis and our alternative hypothesis. And since we're dealing with proportion, we're using P, and since we have two groups, it's going to be group 1 here and group 2 from here. So P1 is going to be equal to P2, as is usual for null hypothesis. And for the alternative, we go back to the claim, and the claim saying that the fatality rate is higher for those not wearing a seatbelt. And those not wearing a seatbelt were group 1. So we're going to say group 1, P1, is greater than group 2, P2. Now that we have everything written out, we are now going to test the claim, and the easiest way to do that is going to be with a calculator, but if you would like to use the formula, you are more than welcome to, but I am going to use a calculator. So, to do this, we're going to go to Stat, Tests, and since we have two groups, two proportions, and we're testing it, it's going to be a 2 prop z test. And so we have everything we need to have written in, already typed in, but if it's not, you can just type it in from what information we already wrote out off to the side. So everything just goes in order, as you see. And then the only one thing you need to be worried about is this. Do we use not equal to, less than, or greater than? And that always comes from the alternative hypothesis. So since it's greater than, we're going to have greater than selected. Then we go down to calculate, and we're going to get all these values. Now, there's a bunch in here, all well and good, but we're only really focused on the first two, Z and P, with no little hat, just Z and P. Z is our test statistic, and P is our P value. Now, it's 5.1, but P can't be greater than 1. So if you look down here, you see that it's E raised to the negative 10th. So that means we need to move the decimal place over 10 spots to the left, which essentially makes P 0. So I'm going to write in our test statistic and our P value. So our T stat is Z equals 6.11, and our P value is equal to essentially 0. Now I'm going to do the p-value method to test the claim. So I'm going to take my p-value and compare it to my alpha value, 0.05. So 0, in this case, is less than 0.05. And since the p is low, we are going to reject the null hypothesis. So when the p is low, we reject. Now, typically you need to write in a sentence or two describing what's actually going on, so that's what I'm going to do now. I'm going to go up here and just type in what is actually going on. So when you reject, that means you typically have enough evidence. So I can say that there is sufficient evidence to support the claim that the fatality rate is higher for those not wearing seat belts. So when we reject the null, we have enough, we can say it was sufficient evidence because we're testing the claim that the fatality rate is higher for those not wearing a seatbelt. So since we're rejecting, that means we're accepting this as the most likely answer. And that is what the claim says up here, so there is sufficient evidence to support the claim. Now what if we want to do a confidence interval? Well, we're going to go through a lot of the same stuff. It's particularly just using the calculator. So bring the calculator back up, and we're going to go into stat, test, and before we did a 2-prop z-test, now, since we're trying to find an interval, we're going to do a 2-prop z-int. So B, so 2-prop z-int for interval. Hit enter, and the information should already be entered in from before. If it's not, just key it in the same way we did before. But the one you gotta be mindful of is the confidence level. And you'll get that from here where it says construct a 90% confidence interval. So we want to be 90% confident. So 0.90 or 0.9. Go to calculate, enter, and here we have our confidence interval. 0.00559 to 0.01226. So that is our confidence interval between these two numbers. So 0.00559 to 0.01226. And one thing you need to be mindful of is when we get this confidence interval, it's the p-hat1 value minus the p-hat2 value. So the first proportion minus the second proportion. And the only way for these values to all be positive, because they are all positive right here, is for the first value to be greater than the second value. And since the first value is greater than the second value, we get only positive numbers, which means that the proportion of people dying without a seatbelt should be higher. So that's what it shows right here. So we need to actually go in and state that claim. So get rid of the calculator and come on back. And I can state that since the interval limits are both positive, it shows that the fatality rate is higher for the first population. The first population being those not wearing a seatbelt, which is those not wearing a seatbelt. And again, this kind of just reinforces what we found before, where this evidence is the fatality rate is higher for those not wearing a seatbelt for the hypothesis test, and the confidence interval is mirroring that, which they should. So we should feel good that this is the correct answer. Now, what do the results suggest about the effectiveness of seatbelts? Well, there's a bunch of different ways you can go about saying this, but I think simplest is easiest. What does this say about the effectiveness of seatbelts? The results show that seatbelts are effective in reducing deaths during, I won't say car accidents, just during accidents. So the results show that seatbelts are effective in reducing deaths during accidents because those who didn't wear seatbelts had a higher rate of dying. There we go.